Hello friends, welcome. Today we'll be doing a question related to double line to ground fault. And the question is, there is a three-phase synchronous generator which produces 8 per unit subtransient current for balance fault at its terminal. Okay, and the zero sequence reactance is 10% of the positive sequence reactance, and the neutral of the generator is solidly grounded. Okay, so he's asking what is the symmetrical current flowing through the neutral during double line to ground fault. Okay, so how to proceed here? Xn is given to us, that is the neutral is solidly grounded, had Xn is 0. Okay, and one more information is given to us, that zero sequence is 10% of the positive sequence, and uh, the generator produces 8 per unit subtransient current for a balanced fault. Okay, so how to use this information? So balanced fault means only positive sequence reactance will come. Okay, so we can write 8 is equal to 1 over x1 or xd double dash. Okay, so if you calculate xd double dash from here, it will come out to be 1 over 8. Okay, so if you calculate this will come up to be 0.125. Okay, so let us say this is the magnitude. Okay, the magnitude will come out to be 0.125, or xd double dash is equal to j 0.125. Since we are not given any information related to the steady state, so let us consider that this is our x1. So our x1 is j 0.125. Okay, also let us consider that it is nearly equal to x2, which is the negative sequence impedance. So now we have both positive and negative sequence impedance, and the zero sequence impedance is equal to 10% of that. Okay, it's given here. So it will become 0.1 into j 0.125, hence x naught will be j 0.0125. Okay, so now what we will do is we'll draw the equivalent diagram during double line to ground fault, and then we will calculate the desired result. Okay, so how the diagram will look like? This will be x1. Okay, and this will be the voltage source. Okay, so this will be the positive sequence network. Okay, and in double line to ground fault, all the three networks are in parallel. Okay, so this is x1. Now x2 is this. Okay, and this will be x0 and xn. Okay, now here we have all the information. Okay, this is 1 per unit. Now x1 is 0.125. Okay, j 0.125, and x2 is also j 0.125. Okay, and xn is 0. Okay, and x naught is 0.0125. Okay, so this is our x naught. Now once we have that, what we can do is we can calculate our current I1, which is a positive sequence current. So I1 will be simple KVL equation is there. So here what we can do is we can find the equivalent impedance across this for this two parallel paths. Okay, now here x2 will be in parallel with uh, x0. Okay, and then if you calculate this will be j 0.125 into j 0.0125 over j 0.125 plus j 0.0125. Okay, so this is that value. Okay, and you can calculate this thing, and you can add it to x1, and when you divide it with respect to this voltage, you get the current I1. So I1 is 1 over x1 plus x2 in parallel with x0. Okay, now why x0? Because xn is 0 here, only x0 will remain. Okay, so if you calculate this, okay, if you calculate this comes out to be 22 by 3 per unit. Okay, so this is the current that you will get. Okay, I1 as. Now once you calculate I1, what you can do is we can apply the current division rule, because this is now the current I1 and we have two branches here, okay, as shown in the previous slide. This is x0 and this is x2. Now you know that x2 is already known to us, which is j 0.125, and x0 is also known to us, which is j 0.0125. okay, so now what you can do is, I1 is already known, which is 22 by 3 per unit. So the current I0 is, by current division rule, is x2 over x2 plus x0 into I1. okay, now you can place these values here. It will come out to be 0.125 over j 0.125 plus j 0.0125 into 22 by 3. So if you calculate I0 from here, I0 you will get as 20 by 3 per unit. okay, so this is the zero sequence current which is flowing. okay, now the total current which will flow through the neutral of the generator will be 3 times this value. okay, so it will be I0, 3 I0 is equal to the current which is flowing through the neutral of the generator. I call it as IN. So IN will be equal to 3 into 20 by 3, and this will be 20 per unit. okay, so the answer to this question is 20 per unit. okay, so this is how you can proceed for this kinds of problem. okay, so I can write here the answer is 20 per unit. okay, so this is how you can solve this problem, and thanks for watching.